Hi guys. Here is a video on how to interpret and use force versus time graphs. Um, this would be objectives 4 and 5 in your or on your objective sheet. So if you want to hit pause real quick for a second and pre-rank yourself on those, that would be a good idea. All right, so what we're going to talk about now is what are the graphs we're going to be doing for this unit. Okay, um, so I've kind of constructed a little XY axis here. It's a little bit clumsy looking. I'm using my touch screen, so you'll have to forgive me a little bit. It's not as clean as I'd like it to be, but it'll serve its purpose. You'll see that I've numbered these a little bit strange, like 1, 2, 3, 4, then 5, 6, 7 are up here. You'll see why I did that here in a little bit. That'll be in a later video, um, but it'll all make sense. All right, so what we're gonna do here is we're gonna kind of look at just first how do we make these graphs, things like that. What's the significance of these graphs and things like that. Okay, so let's say that some force of, and we're going to keep this real simple, real easy for now, force of 1 Newton is applied for 2 seconds. Okay, so the force applied is 2 Newtons, and we'll say it's positive, so it's to the right. And it does that for 2 seconds. All right. So how would we graph that? So what we do is we just come over here to our axes here, and we would just literally need to go up to the 2 Newton for 2 seconds and make some lines here. Now, one thing I recommend here, it doesn't specify when my time interval starts. So what I would recommend is always starting at about 1 second or 2 seconds. Don't start at 0 seconds. And the reason for that will become clear later. It gives you some room to do some things, and you'll see why. So basically, what we would have here, if we have a force of positive 2 Newtons for 2 seconds, it's just going to go from, I'm going to start this thing at 1 second. All right. It's going to go for 2 seconds. So 2 seconds means it's going to go to 3 seconds. All right. So basically, my graph's going to look like this. Oh, I missed there. Sorry, guys. I'm trying to use my touch screen and it's not wanting to cooperate. Pretend that's a straight line, and pretend that goes straight over at 2 seconds there. So basically, what we get is it kind of looks like a bar, kind of like a bar graph, but this is what it ends up looking. So we have this force that is applied from, and let me see if I can clean that up. That's just, all right, that's a little better. All right, there we go. That's a little better looking. Anyways, we get this force that is applied for 2 seconds, um, and for 2 Newtons. Okay. Now, some things that we've got to keep in mind. What are some of the relationships that we know? So if we come over here to these equations, all right, remember that impulse is force times time. So what you're looking at here is really a representation of the impulse. Okay. So if you take a look at this area here, all right, the area between the curve and the top of that line there, that is an impulse because there is the force that's being applied here, and then the length of time from 1 to 3 seconds. So this would give us an impulse of 2 times 2, or 4 Newton seconds. And if we take a look at the graph here, that would be what the area of that under that curve would be, right? We've got 2 newtons high, it's 2 seconds long. So this area here, yes, we're still doing area under the curve. This area here would be the impulse. And so by calculating that area, we would get an impulse. Now, we also know that impulse is equal to the change in momentum. So it's final momentum minus initial momentum. So that means that on this graph right here, at any point from 0 to 1 second, all right, the momentum isn't changing because there's no impulse. There's no impulse from there. So at that point right there, that is our initial momentum. All right, so our initial momentum would be right there at any point from 0 to 1 seconds, because like I said, the momentum is not changing there because there is no force being applied. Now, after that, right there, oops, sorry, let's see if I can get, after that, after 3 seconds, that would be our final momentum. That's supposed to be PF. There it is. All right. So that would be our final momentum. All right. So if we wanted to say, you know, the object initially starts at rest, 0 meters per second, and it has a mass of, let's say, 1 kilogram. Let's just keep this nice and simple. All right. What would be its velocity at 3 seconds? All right. Well, this is absolutely something we can do. All right. So if we're taking a look here, this would be, we know that impulse is equal to force times time, which we have already established is 4, and that's equal to final momentum minus initial momentum. Well, the initial momentum is going to be 0 because momentum is mass times velocity. The initial velocity is 0, all right? So that's going to go away. And so that means that 4 is equal to the final momentum, which is equal to the mass times the final velocity. Well, the mass is 1, so at the final velocity then has to be 4 meters per second. All right, so our final velocity would be, and on this graph that occurs at 3 seconds, our final velocity would be 4 meters per second, and that would be v3. Okay. Now, forces don't have to be positive the whole time. They can be negative. If we graph a negative force like this, like so, one star, and I'll have it go down to, you know what, I need to change my arrow here. I'll have it go down to -1, and I'll just do it for 1 second, like so. Now, if I did this, all right, we can still calculate this area here, all right? This area here would be -1, so the force would be -1 for 1 second, and so the area here would be -1 Newton second, and so that would be the impulse there. All the negative means is that the force is being applied to the left instead of to the right. Okay? And so that's the only difference there. So graphically, that's all that means, and realistically, that's all that means. Okay? All right, so like I said, to review real quick, the force versus time graphs, these little graphs here, this represents an impulse because it's a force acting over a time. To find the value of that impulse, we find the area under the curve. Remember that impulse is the change in momentum, so before the impulse would be our initial momentum for that interval, and then after the impulse would be our final momentum, and we can use our equations that we've already discussed before up here to calculate velocities, masses, final momentum, initial momenta, etc., etc. Okay. All right. Video number 2 will be coming here in a second, but here's a good outline of what these are. If you take a look at this worksheet, hold on, got to find it for you. This worksheet right here, what we just went through, okay, these force versus time graphs will help you through 1 through 5. Okay. Now, as of right now, I am planning on still having the quiz tomorrow, and this information will be on the quiz tomorrow. I will plan on going over some review and things like that ahead of time, but if you can do 1 through 5, that is half of the quiz. The other half of the quiz will be like number 6. Now, number 6 doesn't have, like the worksheets that you have has a hand drawn in graph here. Mine doesn't, so I'm going to show you, that will be the next video to show you how to do that. So half of like the quiz tomorrow, 1 through 5, the other half, number 6. Okay, so that second video will be done here shortly, and then you'll be watching that one after this one. All right, we'll sign off for now, and